String theory is the attempt by theoretical physicists to create one theory that can be used to explain all of the forces in nature. It does this by explaining all elementary particles and all their interactions in terms of tiny, vibrating strings of energy. These tiny, one-dimensional strings of energy in string theory are believed to be so small that if you expanded the universe so that a hydrogen atom, an atom with just one proton in the nucleus and one electron circling it, was the size of our galaxy, the string would still be just the width of a human hair. That's how small it is. Physics is about how objects interact with each other, and at the most fundamental level, there are only four interactions that particles go through: gravitational interactions, electromagnetic interactions, strong nuclear interactions, and weak nuclear interactions. Gravity is explained by Einstein's theory of general relativity, but the other three interactions are explained by quantum physics. The problem for physicists is that these two explanations occasionally come into conflict, which means that neither of them can be the whole story. The nice thing about string theory is that it provides a framework in which all four of these forces can be combined together. Quantum physics explains three of the forces using special types of particles called bosons. Some physicists have tried to explain gravity in the same way, and they predicted a new theoretical type of boson called a graviton. In the early 1970s, physicists analyzing early forms of string theory discovered that one of the mathematical results was a particle which actually, and surprisingly, matched the properties of the graviton. In other words, string theory, which came out of quantum physics, seemed to have gravity as a necessary consequence. It seemed that this might be a way to get one unified theory that explained all four forces. In the years since, string theory has gone through many transformations, but that key insight continues to lie at its heart. Today, physicists around the world are working to see if string theory can be tested, perhaps in the Large Hadron Collider or using powerful telescopes. Many physicists believe that string theory may provide keys to some of the deepest mysteries in physics: possible extra dimensions, black holes, dark matter, dark energy, and maybe even the origin and fate of the universe itself. To learn more, pick up a copy of String Theory for Dummies wherever books and ebooks are sold.